In this challenge, you should create a bank account class. This should have a type indicating the type of account, like checking or savings or some other type. It should have a balance, the initial dollar amount in the account. You should also create a bank customer class that has a customer name, a customer ID, and a list of accounts. You should use the techniques I discussed in the last videos to design these classes. Create a couple of instances of bank customers, confirming that you can't change a customer's data at all after it's initialized. Create a subclass of the bank customer and confirm that the subclass can't tamper with the customer's data as well. Okay, so it's time for you to give that a try. When you've got that built, come back and we'll walk through my version. I'm going to use these two classes in challenges coming up, so make sure to either create your own classes or walk through it with me now. I've created a new project called Immutable Challenges with the usual main class and main method. I'll start with creating the bank account class. I'll put it in a different package, dev.bank. I'll include a very simple enum for my account types. You can imagine this might grow with different account types. I'll include this as a nested type and just set it up with checking and savings to start. Next, I'll set up my two fields, account type and balance, and I'll make these private and final. An enum value is an immutable type, so neither of these fields are subject to side effects once assigned. This isn't going to compile unless I assign values, either directly with an assignment here, which wouldn't make any sense for these fields, or in a constructor. I will generate the constructor using both of my fields and leave that as is. I'll generate some getters for both fields. Next, I want to generate the toString method, generating that with no fields. I'll return a formatted string that prints the account type and the balance with 2 decimal places. I'll test this out in my main class. I'll create a local variable, type bank account, named account. I'll assign that a new bank account instance, passing the checking enum constant and 500 as the initial deposit. And I'll print that out. Running that. I see that I have a checking account with $500 in it. This class can be called immutable. Once created, I can't change the type or balance. Now, this may not be very realistic if I'm writing a banking application. On the other hand, if I'm writing a service that will pass my bank's accounts to some sort of clearinghouse, for example, I wouldn't want these classes to be tampered with. Next, I'll create the bank customer class, also in the same dev.bank package. I want to set up a private static field. I'll call it last customer ID, setting that to 10 million. This will be my customer ID generator, and I am starting the ID with 8 digits. I'll add 2 instance fields, name and customer ID, and I'll make these both private and final. The last field I'll add will be a list of bank account. I'll make this private and final, calling that accounts, and I'll make this a new array list. I'll generate a constructor. For this one, I only want to pass the customer's name. As you would expect, the customer ID will be generated, so it doesn't need to be passed to the constructor. I'll change this constructor to include a checking account balance, as well as a savings account balance. I'll add a double called checking amount and another double savings amount. Now I'll initialize the rest of my fields in this constructor. First, I'll assign last customer ID to my customer ID field and increment that with a postfix increment. I'll add a new bank account, a checking account, with the past checking amount. This gets added to my accounts list. I'll do the same thing for a savings account, passing the savings amount, adding this to my accounts list. I'll add getters by generating them for the name and accounts fields. I'll leave these as is for the moment. I'll include a toString method. I'll remove the return statement. I want to include all the accounts in this string. I'll start with a string array called account strings, and that will be a new array, the same size as my accounts list. I'll populate each element in that array with the string representation of each account. I'll do this by calling arrays.setAll, get the account using the lambda expressions index, and return the string value of the element at that index. My formatted string will contain the customer name and the customer ID in parentheses, prefixed with zeros up to 15 characters. This will be followed by a new line and tab, and then I'll print my account strings which will be joined by a new line and tab, so each account will print on a separate line with an indent. I'll test this now in my main method. First, I'll comment out the code for the account data. I'll create a bank account for customer Joe. He will be added with a checking balance of $500 and savings of $10,000. I will print Joe out. I'll run this now. You can see Joe with his 15-digit ID prefixed with zeros and his 2 accounts. Let's get Joe's accounts and see if Joe's customer record is really immutable. I will get the account data. I'll call clear on it and I'll print it out. Running that. You can see I was able to successfully clear the accounts. That's probably not good. Can I add accounts manually? Let me try that out. I'll create a new bank account, a checking account, with $150,000 and add that to the accounts variable. I'll again print Joe here. And running that now. You can see I made Joe a lot richer than he was initially. Fortunately, I can prevent this last behaviour fairly easily by making bank accounts constructor package private, so let me do that. Removing the accessor altogether. This gives me an error now in my main method, which is good, so I'll remove those last 2 statements. Also, if I want to create a subclass of bank account, look what happens if I try. You can see I can't do this because there is no default constructor available on bank account. And let's say I add a constructor that matches the signature of bank account's constructor and simply try to call it. Here too I have an error on that call to super. It's saying that bank account is not public, it's also not protected, so this means I can't create a subclass of bank account from any package other than dev.bank. That's a good thing. I'll remove that class from my main.java file. Okay, I'm partially there. I demonstrated that I could create accounts from any classes, not in the same package as the bank account class. To prevent this, I need to fix my get method on bank customer. I'll have it return a new array list initialized with the current account's data. If I run this code now, I see the results look a lot better. I'm still calling clear on the account's data I get back from the bank customer class, but it's now only a copy. It's no longer changing the data on bank customer. Effectively, I've got a bank customer with accounts for which I can view the data and get a copy of some of the data, but I can't modify any of it. In the next video, I'll be talking more about defensive copies, both shallow and deep, and I'll follow that with an introduction to unmodifiable collections, so keep this code handy. We'll be coming back to it in other challenges coming up in this section. See you in the next video.